Good evening, dear students. We are going to discuss now about the circles associated with triangle. Now, before I proceed further, just couple of you can confirm that you are able to hear my voice very clearly, able to view the screen properly, or if you find any issue, dear students.
Yes, evidence.
Okay. So, what we are going to discuss in this section, we will explore different circles and um, different circles that are associated with triangle, and we will see the relevant formulas. And dear students, like as I said earlier when we started discussing, if you remember those formulas, you will see that the problem solving become much easier. But first we need to know what are the different circles that are associated with triangle. The first one is called the circumcircle. Okay, what is circumcircle? So first let me show it to you, and then we will discuss about the circumcircle. Circumcircle is a circle which passes through the three vertices of the triangle. That is called the circumcircle. That means what? Suppose let me draw this diagram. Let me use a different color. In the digital board, the only problem I face is drawing the diagram. So let us consider a triangle ABC. And dear students, and if you see the circle what I draw in the red color, that is a circumcircle. That means what? It passes through the three vertices of the triangle. That is the definition of circumcircle. Now what is circumcenter? As you see, what is circumcenter? Circumcenter is nothing but the center of that circumcircle. That is what is called circumcenter. Okay. Circumcenter is the point of intersection of the perpendicular bisectors of the sides of the triangle. That means what? Now, if you draw a perpendicular bisector, you know that the bisector of AB, bisector of the line BC, bisector of the line CA. More than line, I can say there are line segment. So bisector of the line segment AB, perpendicular bisector definitely. So if we draw the bisector in a different color, suppose I draw a bisector of okay, let me use a different color. Yeah, bisector of the lines, perpendicular bisector of AB, perpendicular bisector of BC, and perpendicular bisector of CA. So maybe it doesn't look like good, so it will be something like this. Okay, and they actually converge to a point, and that point is known as the circumcenter. And dear student, that what is the circumradius? Circumradius is nothing but the radius of that circle under discussion. That is the circumcircle. That is called the circumradius. What we are going to find it here. We are going to find what is the circumradius R. Circumradius is denoted by capital R. The circumradius is denoted by capital R, and we can obtain that circumradius capital R by means of any of these formulas, as you see, dear students. And these are the formulas we had discussed in our previous classes. Video lectures of all these classes are available. So what is the circumradius formula? Circumradius formula is equal to a by 2 sine a, or you can write b by 2 sine b, or c by 2 sine c, or abc by 4 into delta. Now what formula you are supposed to use based on the what data has been given to you? If all the three sides are given to you, then it is better to use the formula is ABC by 4 into delta. Because the moment all the three sides are given to you, you can find that area using that Heron's formula, square root of AC into S minus A into S minus B into S minus C, where where AC is the semi-perimeter of the triangle, that is A plus B plus C by 2, and you can find it out. Or if you see that only one side and its opposite angle is given, no problem, then you can find that suppose the side A and its opposite angle, that is capital A, is given to you. No problem, you can find that side A by 2 into sine A. That's it. That is the circumradius. That is what is called the circumcircle formula. I hope it is clear, dear students. Next one what we are going to discuss is called the incircle formula. What is incircle? And before that, we need to understand that how an incircle is actually being constructed. So it says that suppose you have a triangle, okay, and you find the internal bisectors of the angle of the triangle, and then the point of intersection of those three lines. What are those three lines? They are the internal bisectors of the angles of the triangle. Okay, and what an incenter looks like, dear students. Incenter, it looks like something like this. Maybe my drawing may not be very accurate, but it is a circle. Let me draw the circle like this. Yeah. So this circle is called the incircle, which touches all the three sides of the triangle. Okay, and sides it touches and the circle is inside the triangle. So how we obtain, dear students, is that this is one thing, and another way you can look into the same incircle is that let's have the point of intersection of the internal bisectors of the angle of the triangle. What are the internal bisectors of the angle of the triangle? So this is an internal bisector, this is an internal bisector, and this is an internal bisector. Then these three are actually coming to a point. So this is called the incenter. And what is that is called the incenter? I hope it is clear, dear students. Incenter is the point of intersection of the internal bisectors of the angles of the triangle. And what is in radius? Nothing but the radius of that circle under discussion. That is, in radius is nothing but the radius of that incircle. And generally it is denoted by lowercase r. If you recall, dear students, that when you discuss about the circumcircle, the corresponding radius that is known as the circumradius is denoted by capital R. But here in the incircle, that the corresponding radius is in radius is denoted by lowercase r. And we can obtain that value of lowercase r, that is the in radius, in different ways. And which one to choose, that depends on what kind of formulas has been given to us. What kind of data is given to us, not formula, dear students, what kind of data is given to us. So this is one flavor, that R is equal to delta by S. So if you know the semi-perimeter or perimeter of a triangle, and you know the area of the triangle, you find that in radius we are going to use this one. If you know the semi-perimeter and one side and the corresponding opposite angle, then we can use this one. If we know the three angles, means three angles is not required, two angles is given, means you can find the third angle. If you know the two angles and the side which is included between them, then you can use the third formula. Or you know all the three angles and the circumradius of the triangle, then also you can use this formula. You may ask, sir, can't we derive these formulas? Absolutely, we can derive. Okay, but more than derivation, what is very important is that you need to remember this thing, and also you remember this in the same cyclic nature what we discussed earlier. You just remember one particular formula of a pattern of a particular type and follow the same pattern using the cyclic nature. That means if you replace A by B, then definitely you need to replace B by C and C by A, both for the sides and for the angles. So this was related to the Incircle formula. Correct, dear students? Any doubt here? Okay. Now, the next point, any doubt, just tell me. If you have any doubt, then we can discuss. Okay, great. Now, the next point what we are going to discuss, dear students, is called the excircles. Okay. Now, what is excircles? First, let me describe you, and then we'll discuss the relevant, formulas. And I'm telling you, dear students, you no need to remember all these formulas in one day. It is not required also. But at the same time, you should remember all these formulas over a period of a month. Okay, and all these relevant problems you will get into the online platform at KonarClasses.com. Okay, and remember in a very sequential manner, so that it stays in your mind, okay, forever. So what is Excircle formulas? Okay, so the center of the ascribed circle opposite to the angle A, okay, is the point of intersection of the external bisectors of the angle B and C. The internal bisector also passes to the same point. So if I explain you, this thing is that the center of the ascribed circle opposite to the angle A. Let me first draw the angle, triangle. Okay. Suppose this is ABC. Now, the center of the ascribed circle opposite to the angle A. Opposite to the angle A. Opposite to the angle A is what? This side. Okay. The point of intersection of the external bisectors of the angle B and C. See, angle B and C has two bisectors. One is that internal bisector. Okay, and another one is that external bisector. Angle B, if you see that internal bisector is this, and external bisector also you can find it out. So let me give you the diagram properly so that it will be very clear to you to understand. So just a minute, let me give you the diagram. Okay, let me first show you the diagram. Just a minute, let me remove this thing and let me keep the diagram here. Yeah. So I'm just showing one circle. Okay. So the center of the ascribed circle opposite to the angle A. Okay, let me revisit the statement and also explain in parallel. Okay, excircle is that there are three excircles, by the way. The center of the ascribed circle, the center of the, what is, excircle, excenter actually, of the ascribed circle, opposite to the angle A, opposite to the angle A, okay, and its center is ascribed, denoted by I1, okay, is the point of intersection of the external bisectors, okay, of the angle B and C. If you see, dear students, angle B has an external bisector will be something like this. If I draw with it, external bisector will be something like this. And here also external bisector will be something like this. They meet in the point. That is called the, this internal bisector also passes to the same point. Okay. That if you make their, internal bisector, okay, that also the internal bisector also passes to the same point. So that is, let's not get into that discussion, but how we find that excircle first. So to draw the excircle is that first it is a circle whose center is the point of intersection of the external bisectors of the angle B and C, and which is with respect to the angle A, we are saying that opposite to the angle A. So radius of this circle, what I have drawn here, dear students, is known as R1. In the similar manner, you can have the two other excircles. What is R2? R2 will be the, that radius of that excircle, okay, with center is denoted by I2. It should be ascribed circle opposite to the angle B and is the point of intersection of the external bisectors of the angle C and angle A. Okay, so this is called the excircle. Now R1, R2, R3 we can obtain. So what are the R1, R2, R3? R1, R2, R3 are the radii of the excircles opposite to the angles ABC. In the diagram, dear students, whatever I have shown to you, in the diagram, whatever I have shown to you, that is the excircle opposite to the angle A. In the similar manner, you can construct the excircle opposite to the angle B and angle C. Now, what is R1? R1 is the radius of the excircle opposite to the angle A. What is R2? R2 is the radius of the excircle opposite to the angle B. And R3 is the radius of the excircle opposite to the angle C. And how we can find the value of R1, R2, R3? We can find the value of R1, R2, R3, dear students, like this. R1 is equal to delta by S minus A. R2 is equal to delta by S minus B. R3 is equal to delta by S minus C. This is one flavor. When to use this flavor? When we know the area of the circle, area of the concerned triangle ABC and the semi-perimeter and one one side, then you can use this one. If we know the semi-perimeter in any of the three angles of the triangle, then you can use the second flavor, that is R1 is equal to S tan A by 2, R2 is equal to S tan B by 2, and R3 is equal to S tan C by 2. When you know the two angles and the side adjacent to those two angles, then you can use the third flavor, that is R1 is equal to A into cos B by 2 into cos C by 2 by cos A by 2. R2 is equal to B into cos C by 2 into cos A by 2 by cos B by 2. And R3 is equal to C into cos A by 2 into cos B by 2 by cos C by 2. You can use the fourth flavor if you know all the three angles. In fact, if you know two angles of a triangle, you can find the third angle. So that means if you know the two angles of a triangle and the corresponding circumradius of that triangle, then you can find the value of R1 as equal to 4R into sin A by 2 cos B by 2 cos C by 2. R2 is equal to 4R sin B by 2 cos C by 2 cos A by 2. and R3 is equal to 4R sine C by 2 sine cos A by 2 into cos B by 2. Same pattern, dear students. Only one pattern you need to remember for this particular type. Rest will always follow. Rest will follow accordingly. So this is about the Excircle. Okay. Now, what I'm going to discuss now is some important terminologies as long as the triangle is concerned and their corresponding formula. So these are the the points of discussion now, and I will take another 10 minutes to complete this, and that will be a logical conclusion. So some important terminologies related to the related to the triangle. The first one is that the length of medians and angle bisector. Okay, and here goes the formula, dear students. So if you look into this one, that let MA and GA, okay, let the picture come properly to you. Let MA and GA be the length of a median and the angle bisector from the angle A. Purposefully, I didn't draw the diagram. You can visualize it. You can draw it also if you wish. MA and GA be the length of a median and an angle bisector from the angle A. Then we can find the value of MA and GA, okay, accordingly. This is the formula for MA, that is equal to 1 by 2 into square root of 2b square plus 2c square minus a square, and GA is equal to 2bc into cos a by 2 by b plus c. One point to be noted that MA square plus MB square plus MC square is equal to 3 by 4 into a square plus b square plus c square. So these are the little advanced formulas, dear students. And I repeat what I said few minutes back, is that you need to remember these formulas and terminologies. Terminologies you need to know, but to remember these formulas, we need to go in a sequential manner. Okay, without remembering the very important formulas, please do not jump into remembering these formulas now. Now, the next point is that what we are going to discuss about the orthocenter formulas. Okay, what are the orthocenter formulas? Let me keep it in the next page. Orthocenter, dear students, I hope all of you are aware of it, but still let me tell you once. Suppose the ABC is a triangle, as you see, and AD is the perpendicular to BC. That means from the vertex A, we draw a perpendicular to the opposite side BC, and D is the foot of the perpendicular. Similarly, from the vertex B, we draw a perpendicular to the opposite side AC, and E be the foot of the perpendicular. And from the vertex C, we draw a perpendicular to the opposite side AB, and let F be the foot of the perpendicular. So we got these are the 3 foot of the perpendiculars, dear students, D, E, and F. Now, what is O? O is the point of intersection of these 3 perpendiculars. Okay, and that O is known as the orthocenter. And dear students, this the perpendicular foot of the perpendicular. Okay, if we join, that is D, E, and F, we also get a triangle, and that triangle is known as pedal triangle. We will discuss in some other classes to discuss details about the pedal triangle, but today it is not our discussion. Okay, only we'll discuss about the fundamental or the what is the circumradius of the pedal triangle and the area of the pedal triangle, but in details we will discuss some other class. But what is the value of OA? The value of OA is equal to 2R cos A, OB is equal to 2R cos B, and OC is equal to 2R cos C. What is the value of OD? OD is equal to 2R cos B cos C, OE is equal to 2R cos C cos A, and OF is equal to 2R cos A cos B. What is the circumradius of the pedal triangle? Circumradius means what, dear students? Sorry. Let's consider the triangle DEF. Forget about the, for the time being, forget about the triangle ABC. You just focus on the triangle DEF. If you take the triangle DEF, then you can construct a circle, not dear students. Sorry. That circle's radius is known as the circumradius of the pedal triangle, and that is nothing but it is r by 2. That is where r is the capital R, by the way. Capital R is nothing but the circumradius of the triangle ABC. So what we observe, dear students, the circumradius of the pedal triangle, is nothing but half of the radius of the corresponding original triangle. And what is the area of the pedal triangle? That area of the pedal triangle is 2 into delta into cos A cos B cos C. Circumradii of the the triangles OBC, OCA and OAB and ABC are equal. Means if you find the radius of the circumradius of these triangles of OBC, OCA, OAB and ABC, all are equal. So this is the different terminologies related to the orthocenter, dear students. Now, the last point what I'm going to discuss today before I conclude is the distance between the different centers. Okay, the distance between different centers that I'm going to discuss, and just a minute, dear students. Yeah, the distance between the different centers that I'm going to discuss, and last topic I will tell you, touch base about the external triangle and eccentric triangle formula. So before that, what I'm going to discuss about the distance between spatial centers. What is the distance between the spatial centers? That I'm going to discuss now. So here, dear students, is that the distance between the circumcenter and orthocenter. By this time, you understood what is circumcenter, orthocenter, incenter. So the distance between circumcenter and orthocenter is equal to r into square root of 1 minus 8 cos A cos B cos C. The distance between circumcenter and incenter is equal to square root of r square minus 2rr, where capital R is the circumradius and lowercase r is the in radius. The distance between the incenter and orthocenter is square root of 2r square minus 4r square cos A cos B cos C, where lowercase r stands for the in radius and uppercase r stands for the circumradius. This is this, if you remember, I will strongly recommend you to remember, and it will help you. Now, let us the last topic for today, that is about it is called the external triangle and eccentric triangle formula. So let me first describe this thing to you, and then we will discuss the relevant formula. So as you see, dear students, let ABC be the triangle with 3 vertices I1, I2, R3. The triangle I1, I2, I3 is called the external triangle or extrinsic triangle of the triangle ABC. Now, what about that? What are the different properties that we are going to discuss first? Is that these are the fundamental points that you should remember. And we will discuss all these things in details later. But at this moment, you need to remember this thing as a formula is that the first one is that incenter I of the triangle ABC is the orthocenter of the triangle I1, I2, I3. Okay. Now, the delta, that is the first point. I hope you understood. Second point is that the triangle ABC is the pedal triangle of the triangle I1, I2, I3. We already discussed about the pedal triangle. That means if you join the foot of the perpendicular of this corresponding, centers, then you will get this thing, the foot of the perpendicular drawn from the vertices. If you join, then you will get a triangle that is known as the, the pedal triangle. The third one is that the sides of the external triangle I1, I2, I3 has length 4r into cos A by 2, 4r into cos B by 2, and 4r into cos C by 2. That means what are the three sides of this external triangle I1, I2, I3. And the fourth one is that the angles of the external triangles, we know that angle of the triangle ABC, but what are the angles of the triangle I1, I2, I3? That is the external triangle. That is pi by 2 minus A by 2, pi by 2 minus B by 2, and pi by 2 minus C by 2. And distance between I1 is equal to 4r sine A by 2. Distance between I2 is equal to 4r sine B by 2. And the distance between I3 is equal to 4r sine C by 2. So this is all about the external triangle formula. And also we call it as eccentric triangle. So with this, I would like to conclude the class for today here, dear students. We made a logical conclusion. Now in the next class, what we will discuss, next class we will discuss about the polygon formulas. Okay, and those polygon formulas also will be very important. And today what we discussed about this, different circles and their different terminologies, I give a very brief overview of it. Later, in some other class, we will discuss in details about all these formulas and the relevant topics. But for the time being, you need to remember all these things, very well, because these are important. And if you remember this thing, it will help you to solve problems very efficiently. With this note, I would like to conclude the class for today, unless you have any specific question for me. Thank you.
Thank you, sir.
Yeah.